headed in on that, and it's actually really awesome. It mostly covers kind of like how to use fuzzing to find vulnerabilities in applications, and then actually, like once you get the results back from it, how do you know how long to run your fuzzing and what to do with the actual information you get back from it, and how to really get video covered and stuff like that. So, really awesome talk we did yesterday.
Can I use that outlet under you?
And I hope you guys all enjoy it. Thanks. Here's Carl's luck.
Thank you.
Thank you for the introduction. That's pretty much exactly what I'm going to cover today. Like you said, I gave a long talk yesterday, and I have a look at files and programs and stuff that goes along with this talk, and I'm going to put those on my OpenRC account probably tomorrow or something. So if you want those files and you can't find them, just send me an email and I'll set you up with them. Okay, so what am I going to talk about? First, I'm going to spend a couple minutes just making sure everyone's on the same page about the terms I'm going to use for fuzzing and what fuzzing is all about. Then I'm going to talk about a lot of the problems that you'll run into when you try to do fuzzing. And then I'm going to move on to code coverage, which is kind of what it talks about, which is something that I'm going to show you can use to sort of answer a lot of the questions that you'll run into when you're trying to fuzz something. Then I'll do a bunch of examples, and then I'll talk about how you can make your code coverage. So, if I had like 5 minutes to describe to you what fuzzing is, and I actually have less than that, this is what it is. So basically what fuzzing is something that QA teams and testing people have been doing for 10, 15 years, and security folks just in the last few years have realized what a great tool it is. And what it is basically inputs into a program, which we'll call test cases. You send those into a program, lots and lots of them, and you make little changes to them, and you watch the program to see if something bad happens. That's basically all fuzzing is. It's just, how do you make the inputs, and how do you monitor the program, and how do you do it better? But, the 3-bullet slide is, you send a lot of inputs into a program, you make malicious changes to them, and you monitor the program and involve them. And so here's basically the simplest example I can think of fuzzing. So, the top line there is a valid HTTP GET request. And underneath there are just some changes I've made to it, so I've added anomalies. So the first thing I did was I replaced the verb get with what it is. Add some slashes, add some %ends, whatever I could think of, I did. And the point, one thing to take away from this is that, well, how did I decide to make those changes? Well, I could have made lots of changes, and obviously I could have made infinitely many things there, right? And so the question is, how do I make these inputs that are in a smart way, and how do I know how do I know how many to make? These are the questions that you might not think of right away. Okay, so anyway, let me explain some more fuzzing terminology and different ways that fuzzers work. So there's basically 3 classes of fuzzers. The first is called mutation-based, second is generation-based, and the third is evolutionary. And I'll talk about all 3 of those real quick. So mutation-based fuzzers, they're called dumb fuzzers, and it's basically because the structure of the inputs to the program, like the test cases, you don't need to know anything about that. The fuzzer just blindly takes inputs, changes them, and gives them to the program. So you start with a valid input. So this is the HTTP example I just showed you. That was an example of mutation-based. So I started with a valid get, and I just started tweaking it. So the anomalies you add, they can just be random. So like, I add a bunch of A's. I could start flipping this, whatever I want to do. Or they could follow some sort of heuristic. So, obviously adding a lot of A's, there was like a reason for that. I was hoping maybe to find a buffer. I added some %ends, and there's a reason for that. I was hoping to find a format string button. So the changes you make can have reason, or they can just be random. Basically, it requires no time to set up. And in my talk yesterday, I did some fuzzing, and it basically took me 30 seconds to get it going. Because I don't need to know anything about it. All I need to do is, have some program that can, arbitrarily take an input, make random changes to it, and send it to a program. It's really easy. You have to be very careful, though, with this type of fuzzing on any protocols that have checksums or challenge responses or protocol IDs or anything like that. Because since the fuzzer doesn't understand anything about the protocol, it's not going to know how to fix up those checksums. So the program probably, if there's checksums, first thing it's going to do is check the checksum. If it's not valid, it's just going to kick it out. So your fuzzer is just going to be testing like the first 5 lines of code. It's not going to be testing very much. And then I give some examples of some fuzzers that are of this type. And the next type is called generation-based, and they're called generation-based because you generate the test cases from scratch. So if you notice, if back to the HTTP example I gave on the second slide, if that was me really trying to fuzz Apache or IIS, I'm only going to be fuzzing the functionality of that processes gets, right? So there's obviously way more HTTP verbs like if you do head or trace or whatever. So there's a lot of other things that I'm not fuzzing because I just took one input and I started changing it. So with generation-based, you don't have that problem. You start by reading the documentation, whatever you can find, RFC, and you build up inputs from scratch. So in this case, if I was really going to fuzz Apache, I was going to use a generation-based approach. I'd read the HTTP RFC, and I would figure out all the verbs. I would write responses or write requests that are tokenized exactly like the RFC explains. So usually at the bottom of RFCs, there's some ENF type grammar that will explain how the request will go. But anyway, the point is you build up from scratch. So in theory, you should have every kind of test case that the program would whatever accepts. So you would think that you'll do better with this. And the downside is it takes a long time to set up. So, like I said, yesterday I started a fuzzer. It took me like a minute to get it going. If I wanted to do a generation-based approach, it would probably take me like 2 weeks, a month, I don't know. You basically have to read an RFC and write down in a programmatic way how every type of input could possibly look. And obviously that's going to take a very long time. There's some examples of some fuzzers that are set up to do that, and the last two that are commercial, and their basic business model is let us do that work that took a month and describe all the test cases, and we'll give those to you. The final type of fuzzing that I want to talk about at least is called evolutionary, and basically, so these three types of fuzzing I'm talking about are all differentiated on how you get the test cases. The first one was you take inputs and you change them. The second one is you build them up from scratch, and this one is you somehow generate new test cases from watching how the program behaves. And AutoDAP was the first one that did that, and it basically prioritizes test cases based on whether they hit these dangerous APIs. So if there's obviously either a very, very large number of test cases or maybe an infinite number of test cases. And if you see some that are hitting some string copies or something like that, they prioritize those. The second one, and I'll talk about this one later, is called EFS. And it basically tries to get new test cases that are going to get better code coverage than the previous test cases. Like I say here, this is still like super early, and it's really hard to use. This AutoDAP is like very mature, but EFS is still very, very new and very difficult. Alright, so you downloaded a fuzzer, you read a paper about fuzzing, maybe you read the book on fuzzing, and you're ready to do it, right? And you sit down, you figure you know everything there is to know, right? I explained that first slide to you, what else is there? Well, as soon as you sit down and you try to run these things, you're going to run into some problems. And these are some of the problems you're going to run into that no one's basically told you about. The first is, like you saw in the HTTP one, mutation-based fuzzers generally have an infinite number of test cases that you can set. So the question is, if I can set infinitely many of these, I obviously can't set them all. So when do I stop? Do I stop after an hour, a day, a week? So the question is, how do you figure out when to turn off your fuzzer if it has a bug? Obviously, it's unanswerable in general, but you can actually make some sort of smart decisions. The second one, generation-based fuzzers, they generally generate a finite number of test cases, but still, what happens if maybe it's a million test cases, you run them all, and you haven't found a bug? Are you done? You just go home, or can you do something smart? The third one, how do you monitor the target application? So I told you you're supposed to send inputs in and then watch to see if something bad happens. Well, typically what people do is they attach a debugger to it, and they wait for it to throw an exception. Well, there's lots of things that a program can do that's bad that doesn't have anything to do with exceptions. So you can imagine like SQL injection, command injection, how about, what else could go wrong? You get like a directory transversal. So there's lots of things that go wrong in programs all the time that have nothing to do with it, just falling on space. And the question is, how do you monitor for those types of events? What happens if you find too many bugs? So that sounds kind of funny, but it can happen. So what happens if you've got, every time you send a test case, the program dies, but it always dies in the same spot, and that spot's fully uninteresting. What do you do then? And you'll see that a lot in programs that are not very well written. But still, it makes it where you can't use fuzzing. So say I've sent in 1 million test cases. How do I figure, and the program crashed at some point. I went to bed, I woke up the next morning, I saw that it died. How do I figure out which test case crashed? Or test cases. Maybe it was a series of test cases. And then past that, suppose I figure out it was this test case crashed the server. How do I take that information and figure out exactly what went wrong inside the server? Finally, when you're done fuzzing, how do you know how good a job you did? So maybe I fuzzed something, and maybe some guy up the street set up a fuzzer and ran, and neither of us found a bug. Did I do a better job than him or not? I hope so, but maybe not. Finally, when do you just give up? When have you fuzzed and you've done basically all you can? All right, so here's an example of one of these problems in action. So I have a PDF file and it has 250,000 bytes in it, and these are one of the files you can get off of the OpenRC site tomorrow. So it turns out that out of all those bytes, there's one byte out of it that if you change to certain values, it'll cause Acrobat to crash. And you can't even change it to just any byte. There's just certain bytes that this one byte can be changed to, certain values that this one byte can be changed to that'll make it crash. And it's not at the beginning either, it's actually towards the end of the file that this byte exists. So if you do the math, you figure out that there's that very, very low probability of any particular test case finding this bug. And so if you do some more math, then you figure out, basically on average, you're going to have to send in 127,000 test cases before you'll find this guy. And if you use FileFuzz, for example, which generally sends test cases into a second, that's basically 3 days. So the question is, if you ran a fuzzer and you just turned it on, it didn't find a bug, you wake up, it's day 2, you come back, it's day 3, it still hasn't found a bug. Are you really going to let the thing keep running, or are you going to turn it off at some point? And that 3 days is just an average. Sometimes it might have taken you a week before you find the first bug. I fuzz all the time, and I've never let a fuzzer run more than a day. Maybe that's because I'm not so smart. Okay, so this is another example. 3G2 is a video file format. And I didn't update my slide, but it turned out when I wrote these slides 2 weeks ago, this was true. I have a particular 3G2 file, there's nothing special about it. Turns out if you go through and you start changing each byte to an FI, that QuickTime Player will actually crash 42% of the time. So it's impossible to fuzz QuickTime Player for this file format, because the thing always dies, and it always dies in the same boring spot. The fact that it dies there makes you think, well, this program isn't written very well, so just buy other bugs. But you can't test for those. It turns out since 2 weeks ago, between now and I tried to rerun a couple days ago, they fixed this bug. So they silently fixed this guy. But if you don't patch it for time, you'll find this behavior. All right, so those are some of the problems that when you really try to sit down and do real fuzzing, that you're going to run into. Some of those problems are open research problems, and no one really knows the answer. Some of them I kind of have an idea what to do, but I don't have time to tell you. So just bug me afterwards. And some of them, I claim you can use this concept of code coverage to answer. So what's code coverage? It's basically a tool you can use to figure out how much code in your program has been executed. You can do it for source code or for binaries, although everything you read, except at hacker conferences, is going to say have the source code, because most people do. So there's different kinds of code coverage. I'm going to explain real quick a few of the different kinds.